today's session, I'm going to teach you the concept of clustering. In clustering, we have K-means and hierarchical clustering. So let's start with clustering part. So clustering, it is an essential form of unsupervised learning. An unsupervised learning method is a process by which references are drawn from input data set without marked answers. Okay. So in unsupervised learning, we don't have label data. So we will group the data based on similarities. So generally speaking, it is utilized as a procedure to uncover significant structures, explaining processes, generative characteristics, and group present in number of cases. Okay. So clustering is the task of dividing population or data points into number of groups in order to make data points more similar the other databases in the same group in the same group and different points in others. Okay, so it's basically collection of objects based on the similarities and differences. So clustering is nothing but what you are doing is that you are forming into groups which are having similarities. So you are dividing into multiple groups over there. So whichever belongs to like whichever groups have same similarity will be clustered into one group, and whichever doesn't belong to similar and which is belong to some other kind of characters which shows it is belong to some other kind of similarities will be belong to another cluster. So let me show you the class notes. So clustering, we have K-means and hierarchical clustering. So it's all about grouping the data based on similarities and some characteristic features which are similar. It's a form of unsupervised machine learning algorithm. So the aim is to find similar groups. Okay. So the definition is collection of objects which are perceived to be similar between them and dissimilar to the object belong to different clusters. So let's take, so these are the points. The points you are seeing are, let's say these are some of the data points and we have to group them into form of cluster. So we'll make sure that we will make a cluster. So let's say, so first this group belongs to one cluster and this another group belongs to another cluster. Then in this cluster, we will say this group belongs to one cluster and this group belongs to another. And then here in the next cluster, we have these groups, similar groups are over here, one cluster, and these similar groups are in another cluster, and the remaining are in some other cluster. This is how AFL will form cluster. So the number of clusters you want to have, you can give it based on LO method that we will going to discuss. So first, let me teach you the types of cluster we have. So clustering has two types, hierarchical and non-hierarchical. In hierarchical, we have dendrogram and dendrogram-based clusters, whereas in non-hierarchical, we have K-means clusters. So the use case of this cluster is it is used for Google News. Some Google News recommendation that you get in your Chrome or Google feed is based on the kind of data you have been searching on Google. So this based on your interest, the news will be fed into your notifications. Okay, so similar kind of news will be fed in the browser that you are trying searching the uh, news. Okay, so then we have movie recommendations. So when you watch some movies on Netflix, so the next time you come and check a movie, you'll see that you will have a 98% match or 96% match, like that kind of thing. It's based on what you have previously watched, so that that movie Netflix uses your previous search data and watch data, and based on that, it will recommend you some movies that might interest you. So when you launch a product in the market, it will see the number of features, like new features that are present in the product, and it will generate a class form of cluster like how many users are using that new feature or how many users not using that new features, and You can get the review from the users if they liked it or not. So this is also a kind of clustering. Okay. So let's come to hierarchical clustering. So while there is no need to specify the number of clusters to be produced, hierarchical clustering can be used as an alternative to partition clustering. So the data set is separated into clusters in this technique to form tree-like structure known as dendrogram. Okay, so let me explain you with that. So here, so we have hierarchical clustering. So what happens is that here, um, each of the data points will form a cluster, and each of these data points will form its own cluster. So then we will have how many cluster? 8 cluster. Then it will try to find the nearest cluster, and it will try to form a new cluster. So here 1 and 2 form new cluster, and then if you want another cluster, it will form another cluster. Let me again give you by explaining completely over here. So the data set is separated into cluster in this technique to form a tree-like structure known as dendrogram. So let's not think about it. So let me check somewhere else. So, okay, how does the hierarchical clustering work? So hierarchical clustering is another method of clustering. Here clusters are assigned based on hierarchical relationships between data points. There are two key types of hierarchical clustering, agglomerative and decisive, top-down. Agglomerative is more commonly used as it is mathematically easier to compute, and it is method used in Python's scikit-learn library. So this is a method we will explore in detail. So here is how it works, okay? Hierarchical cluster. Assign each data point to its own cluster. So assign each data point to its own cluster. So the number of initial cluster is equal to number of initial data points. You will agree with me. Okay, so the number of initial clusters will be equal to number of data points, which is 8. Compute distance between all the clusters. Okay, so we will compute distance between from here to here, here to here, here to here, here to here. So we'll compute distance between all the clusters. Merge the two closest clusters. So we'll merge two closest clusters. So here to here is the new closest cluster. And next, what we have to do? Repeat these steps 2 and 3. So step is compute distance between all clusters, merge two clusters, and iteratively until all data points are finally merged into one cluster, one large cluster. That will be a parent cluster. So merge the closest cluster, which is closest distance. So this one will merge first, then 4 and 5 will get merged, and then 6 and 7 will get merged, and then 3 and 4, 5 will get merged, and then this will get merged, and then this will get merged, and then at the end all will get merged. First, if you see in a dendrogram scale like of structure, 1 and 2 gets merged here. Next, 6 and 7 gets merged. Next, 4 and 5 gets merged. In the next form of clusters, we have 3 and 4, 5 gets merged. Next, 6, 7, and 8 gets merged. Okay. Next, this 1, 2, 3, 4, 5 gets merged. 1, 2, 3, 4, 5 gets merged. Next, 8, 6, 7 gets merged. And now next it will form whole cluster. Okay. So this is how agglomerative clustering. This is a bottom-up. Agglomerative is a bottom-up approach where we are computing distance between clusters and merging two clusters that are having a minimum distance until all are merged into finally a large cluster. Okay, so this is about agglomerative, and divisive is so here let's divisive is like you will have only one cluster, parent cluster, and you start splitting from top down. Okay, so this is agglomerative is a bottom-up approach. So you will merge to form clusters. So each observation starts its own cluster. Okay, so each observation starts its own clusters in agglomerative. Pairs of clusters are merged when we move up the hierarchy. So pairs of clusters will be merged when we move up the hierarchy. So subcomponent is visited first, and then we move to the parent. Okay, then we move to the large cluster. So in divisive, cluster. So agglomerative cluster we have discussed till now. So in divisive we have top down. So all observation starts from one cluster. So this is a big cluster we have. From here it will start. So splits are performed recursively as we move down. So this split is performed, this split is performed, this split is performed, this will split, this will split, this will split, this will split. So splits are performed recursively as we move down the hierarchy. Parent is visited first. This is the parent. Okay? These are subnodes. So difference. So hierarchical clustering cannot handle larger data sets very well, but K-means clustering can. So before moving to this differentiation between those, so let's look at how does clustering happen. So we will look at K-means clustering. How does it happen? Before that, let me give a brief on hierarchical and non-hierarchical. So, I stopped here, right? So let me start once again. So while there is no need to specify the number of clusters to produce, hierarchical clustering can be utilized as an alternative to partitioned clustering. The data set is separated into clusters in this technique to form a tree-like structure known as dendrograms. We have already seen that data set is separated into clusters, like data set is separated into clusters in this technique to form a tree-like structure. So we will form a tree-like structure like this dendrogram, okay? By pruning the tree at the appropriate level, the observation or any number of clusters can be selected. So whatever number of clusters you want, you can select by pruning it. The agglomerative hierarchical algorithm is the most common example of this strategy because agglomerative is the bottom-up approach. Okay. So non-hierarchical clustering. So non-hierarchical clustering is the K-means. The K-means algorithm is an iterative procedure that attempts to partition the data set into K unique non-overlapping subgroups. Okay, so we'll give K groups for initially. For K-means algorithm we will mention the K number of clusters. So K is nothing but number of clusters we want, with each data point belonging to just one group. It attempts to keep intra-cluster data points as comparable as possible while keeping clusters as diverse as possible. It distributes data points to clusters in such a way that total of square distance between the data points and the cluster centroid is as small as possible. So this is nothing but I'm going to explain in the class. So this is nothing but there is a method called this Watts linkage. Okay, so minimum error sum of squares we are going to try. So minimum error sum of squares. That's what it is trying to say. It distributes data points to cluster in such a way that total of the square distance between the data points and the cluster center is as small as possible. The lower the variation within the clusters, the more homogeneous the data points inside the same cluster. So this is what they are saying. The lower the variation of within clusters, the more homogeneous are the data points inside the same cluster. The use case of clustering is used for identifying fake news, spam filtering, and marketing and sales to check a particular if there is any particular trend in data marketing and sales we use, and to classify network traffic. So if there is any malpractices or if there is any kind of hacking that has been done in a particular website, so that kind of a classifying network trafficking, so identifying fraudulent or criminal activity, so document analysis and fantasy football and sports. So these are the forms of clustering. These are the use cases where we use clustering. So how does K-means clustering work? So let's see. So K-means clustering is a method for grouping data into numerous comparable groups or clusters which are distinguished by their midpoints, which we refer to as centroids. Before moving to the K-means clustering, so how? Let me tell you how does a K-means clustering happen? So in K-means, let's say you have a city and there is a river between and there is a bridge and there are people around here and people around here and people around here. Okay. So you want to set up a food truck. Like there are three personals who have set up a food truck. So personal A has set up food truck over here, and personal B has set up food truck over here, and personal CEO has set up a food truck over here. So what happens that so this food truck is near for these personals and these personals. So all these individuals will go to food truck A. So this food truck is near for these many individuals. So these individuals will go to food truck 2 and these individuals will go to food truck 3. Okay. So locate random food trucks around the cities we have located. Some logic which when we applied will help in making the decision. So everyone is going to their nearest food truck. Best location to serve is always center point of the location. Hence, a truck will move to the center point. So this truck will move to the center point and go here because this is 2, this is 4. So it will go here. So 3 here and 3 here. So it will go here and here 2. So food truck 2 remains there. But here, what happens is that here this truck will go at the center. So what happens then? So when the food truck 1 goes here, these people will go here. So these many people will go here. These many people will go to food truck 2, and these people. So there is a increase in number of people from here when you move the food truck from here to here. Like people will increase from here. Okay. So now what you have to do once again. So repeat wave and B. Everyone is going to nearest food truck. Best location to service center point of the location in center will move to center point. So now this truck will move here, okay? And this truck, since this truck will move here at this point, so this is for 2, the center point will be this, so that they can cover these many individuals as well. So this truck move will here. So all these individuals will go to food truck 2, and this will remain over here. And food truck 1 will go here, so that all these individuals will go to food truck 1. So this is how the diagram looks. So this is the training, okay? So this the model is trained like this. So one took a decision, number of food trucks. So training means we took a decision on number of food trucks, okay? So how does we know how many clusters we want? So what? How do you go? How are you going to find the number of clusters that you required? Okay. So we have to select k value. So this can be done using elbow method or WSS curve. So WSS curve is nothing but within cluster sum of squares. Okay, a measure of how far away each centroid is from their respective class instances. So let's say the farthest distance between two clusters is from here to here if we have only one cluster. Let's say we have to taken k value as two clusters. So we have two different clusters, so circle and triangle. So the farthest distance is from this triangle till this triangle. Last triangle is the farthest distance. Let's say now we have a three clusters. The farthest distance possible is from here to here, or here to here, or here to here. Okay. Now let's take four clusters. The farthest distance is still be from here to here because we are always measuring the farthest distance. So WSS curve means WSS curve is a measure of how far each centroid is from the respective class instances. Okay. So when you see this graph, you could see that at 3, your distance has reduced a lot. Right? So this was a huge distance over here when you had one cluster. The farthest distance was still high between when you took two clusters. And when we take three clusters, the distance has reduced a lot. Okay. So this has reduced a lot. And when you take four clusters, it is not that much change. It's not it's almost the same as 3, so we don't see a significant change. So we will take number of clusters as 3 in this case. Okay. So WCSS class is a measure of how far each centroid is from the respective class instance. WCSS is nothing but the sum of square distance between each point and the centroid of the cluster. So sum of squared distance between each point and the center of the cluster is WCSS, or this is also known as elbow method. These are clusters and these are WCSS diameter. Okay, this is the WCSS diameter. So based on which we'll try to find the number of clusters that we want. So that is the optimum number of clusters. Okay, is that we do so when you want to know the number of clusters that we have to take. So the optimum cluster number of clusters will be decided using elbow method. You need to understand that. Okay. So now we have covered this dendrogram part previously. So let's see here. Okay. So let me teach you that how does K-means clustering work. So K-means clustering is a method for grouping data points into numerous comparable groups or clusters which are distinguished by their midpoints, which refers to as points. This is how it works. Enter K, the number of clusters you want to find. Let's go with 3. Generate K 3 new points at random on your chart. These are the centers of first cluster. Okay. These are the centers of flush cluster. Calculate the distance between each data point and each centroid. Then assign each data point to the centroid. So this is actually so. Okay. So this will be good. Okay. So enter k number of clusters you want to find. Let's go with 3. So let's say 1, 2, and let's say another cluster we have like 3. Okay. Generate 3 new points at random on your chart. These are the centroids of the first cluster. Okay, these are centroids. Let's say centroids of this cluster we have. Calculate the distance between each data point and each centroid. So let's say for this cluster, this is a centroid, and this cluster, this is a centroid. So calculate the distance between each point and the centroid. Okay, the distance between each point and the each centroid. Then assign each data point to centroid closest to it and cluster it to which belongs. Okay, so we have assigned that which each belongs to. So recalculate the cluster's midpoint centroid. So when you calculate the distance from the centroid, then you have to recalculate the centroid once again. So repeat 3 3 to 4 to allocate data points to clusters based on new centroid position. So we have done the stop when one of the following occurs. Okay. The centroid has been stabilized. No data points are registered after the timing the centroid of a cluster. The maximum number of iterations has been reached. Okay. So how does the hierarchical clustering work? So hierarchical clustering is another method of clustering. Here, so we have already discussed this, right? Yeah. So we have already discussed this. So let's come to the end of the session. So hierarchical clustering cannot handle large data sets very well, but K-means can because the time complexity of K-means is order of n, whereas for hierarchical is order of n squared. So results are not reproducible in K-means. That's one disadvantage because we start randomly, whereas in hierarchically it is possible. So, so coming to the linkage method, so we have 4 types of linkages: single linkage, complete linkage, Watts linkage, and average linkage. So in single linkage, 2 clusters with closest minimum distance is merged. So these 2 clusters are the nearest one. So these 2 clusters with the closest minimum distance is this and this gets merged. Okay, complete linkage is 2 clusters with maximum distance. So this and this, let's say this is the maximum distance and this is the maximum distance from here till here. So these two gets merged. So clusters, so single linkage is 2 clusters with minimum closest distance gets merged. Complete linkage is 2 clusters with maximum distance. So word linkage is minimum error sum of squares. Okay, minimum error sum of squares. So m to point p, m minus p whole square plus m and m. So distance between this and this, distance between this and this, distance between this and this. So error sum of squares. So average linkage is arithmetic mean of distance between all data point in the both the clusters. Okay. Arithmetic means all for distance between all data points in both the clusters. Okay, from here till here, here till here, here till here, here till here, here till here. So all data points from both the cluster distance, mean average, the mean average, or mean of the mean distance, it will calculate. So that is average linkage. Okay. So this is all about four types of linkages: single linkage, complete linkage, awards linkage, and arithmetic linkage. Single linkage is two clusters with minimum distance is merged. Complete linkage is two clusters with maximum distance. Vast linkage is error sum of squares, and average linkage is mean of distance between all the data points in both clusters. Okay, mean distance between all data points in both clusters. So now let's come to evaluation. So how are we going to evaluate our model? So we have to take some parameters. So we have Shilot coefficient. Shilot coefficient formula is given by B minus A by maximum of A comma B, where A is mean distance between a sample and all other points in the same cluster. So let's take the sample and mean distance between this sample and all other data points. So that we are going to consider in the same and all other points in the same cluster. Okay, mean distance between the sample and all the points in the same cluster is A, and B is mean distance between the sample and all the other points in the next cluster. So this is the nearest cluster. The mean distance between the sample and all the other points in the next cluster. So from here till here, here to 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 here, and mean distance it will take this. And then for B, this is B. For A, the mean distance between here to here, here to here, here to here, here to here. So this will calculate the mean distance between sample and all other points in the same cluster, and mean distance between sample and all other points in the nearest cluster. So let's say the B, which is mean distance between a sample and all the points in the next nearest cluster is B is 0. Okay. So next nearest cluster, let's say it's on the A cluster itself. I mean, on that cluster, on the sample itself. Okay, the sample we are taking. The next cluster is on the sample itself. So distance is 0. Okay, and let's say mean distance between a sample and all other points in a cluster. Let's say that's A. Okay, 0 minus A by A, max of A comma B will be A. So that should be minus 1. This can't be possible. Okay, so the a sample, the next nearest cluster cannot be on the sample. And let's say we have a chance that mean distance between sample and other points of an near cluster is B. Let's say B is B. And the next sample is 0. Okay, we don't have the next nearest cluster. So A is 0. So we'll have 1. This is highly loose. Okay. So let's say we have mean nearest plus mean between mean distance between sample and all other points cluster, and mean distance between sample and all other next cluster is same. So A minus B is equal to A kind of thing. Then we get overlapping clusters. Okay. So for using Shilot coefficient, we have to from sklearn dot metrics we have to import Shilot coefficient score, and S is equal to Shilot score of data, comma, KMeans you need to pass. Okay. So let's end this session. So by summarizing, so both K-means and hierarchical clustering are widely used algorithms. Yet they serve different purposes because it is relatively computationally efficient. K-means work significantly better with large data sets, whereas hierarchical clustering, on the other hand, does not perform well with huge data sets due to quantity of computation required at each stage, because we are building a decision tree kind of thing, a tree-like structure. So because of that, it's not performing well with huge data set. but it produces better results for small data sets and allows for hierarchical interpretation, which is useful if your data set is hierarchical in nature. There is no one size fits all answers to practically every machine learning problem, but these two methods, that is hierarchical and K-means, have various use cases, and it is vital to evaluate the nature of the data set when picking which approach to utilize. So this was all about the clustering part I wanted to discuss. So thank you for attending the session. So I will be covering principal component analysis and support vector machine in the next class.